In today's lesson, we are looking at trigonometric equations where we are given the ratio. Now before we start, I would like to focus your attention on the Cartesian plane, and the following is very important to remember. If we go around once on the Cartesian plane, we know that for each of our functions there will be two angles that give us exactly the same answer. Now why? Because on the Cartesian plane, each one of our functions are positive in two different places, and each one of our functions are negative in two different places. Now let's go and have a look. So we are given the cosine of theta is equal to 1/2. So the cosine of a certain angle gives us the ratio of 1/2, and we want to calculate this angle. But now I just said there will be two answers for this angle that will give us the same answer. Now because we want to calculate theta, we know we are busy with trigonometric equations, and to find the other angle we are only going to make use of 180 degrees plus, or 180 degrees minus, and 360 degrees minus. We use only these two critical points when we are busy with trigonometric equations to find the other angle. So let's just quickly calculate this theta. So we can say theta is equal to, and we take the inverse function of this cosine to the other side, and we have cosine to the power of -1, which is the inverse, and we put the ratio in brackets. We calculate this on our calculator, and you will see that theta is equal to 60 degrees. So the cosine of 60 degrees is equal to 1/2. Now this is only one angle, and we still need to find the other angle that will give us the same ratio. Now how do we do this? Well, this ratio is a positive ratio. See, there is no minus. So this is a positive ratio, and the cosine is positive between 0 degrees and 90 degrees, so in quadrant 1, and it's also positive between 270 degrees and 360 degrees, because it's also positive in the fourth quadrant. Now we already worked out the angle between 0 and 90, that is 60. So what do we do to get this angle? Well, we are going to work with 360 minus. So we can write cosine 60 degrees as cosine 360 degrees minus 60, because this is the same as this, as you learned in reduction formula, right? But now, because both of these are angles that we can subtract, we can say 360 degrees minus 60 degrees gives us 300 degrees. So the cosine of 300 degrees will also give us 1/2. So if we go around once, we get two answers for theta, 60 degrees or 300 degrees. If we go around a second time with the second revolution, well, we just add 360 to this one and to this one, and we get 420 degrees or 660 degrees. If we go around 3 times, we again just add 360 to each one of these. Okay, got it? Let's go and look at some examples. Now to answer the following questions, we are going to make use of these 5 steps. So here we go. Sine theta minus 0,574 is equal to 0. And the question is, we want to solve for theta for only one revolution. So we're going to have two answers for theta. Okay, so here we go with the steps. Move our constant terms. Well, minus 0,574 is a constant term, so we move it to the other side, and we end up with sine theta is equal to 0,574. Second step, divide with the function's coefficient. Well, this sine theta is our function, and the coefficient here is a 1, so we don't have to worry about it in this regard, because 0,574 divided by 1 stays 0,574. Then, step 3, use the inverse of the function. Because we're not moving the sine theta, we're only moving the sine, we are going to use its inverse. So we end up with theta is equal to sine to the power of -1, and we put the ratio in brackets. There we go. Then, step 4, move any extra constant angle. Well, with this theta there is not another angle, so we don't need to move that constant angle. Then divide with the angle's coefficient. Well, the angle that we're trying to calculate, the coefficient is only 1, so we don't need to divide with it. And then we just type this into our calculator and we end up with theta is equal to 35,03. Now that's the first angle. Well, now we go to where we find the sine of an angle which is equal to a ratio. So there's the ratio and the ratio is positive. So where is sine positive? It's positive between 0 and 90, and we already have that angle. But it's also positive between 90 and 180 in the second quadrant. So what we do is, because this is an equation, we work with 180 minus. Minus what? Minus the angle that we just had, right? So we will say 180 minus 35,03 will give us 144,97 degrees. And these are the two answers for theta. Okay, wonderful. Let's have a look at another question. So here we are given 2 tangent and theta minus 45 degrees in brackets equals 1. And we want to calculate theta. So here we go. Move our constant terms. Well, on the left side, we don't have a constant term that we have to move. So step 2. Divide with the function's coefficient. Well, the function is tangent theta minus 45 degrees and the coefficient is a 2. So we're going to divide with the 2 on the right side and we have tangent theta minus 45 degrees equals a half. Okay, step 3. Use the inverse of the function. So this tangent will go to the other side as its inverse and we end up with theta minus 45 degrees is equal to tangent to the power of negative 1 and the ratio goes in brackets. Then move any extra constant angle. So this is a constant angle which is extra because it's not part of this theta. So we're going to take this minus 45 degrees to the other side and we end up with theta is equal to tangent to the power of negative 1 in brackets the ratio plus the 45 degrees which was that extra angle. Then we want to divide with the angle's coefficient. Well, theta doesn't have a coefficient other than a 1, so we don't have to do it. We type this into our calculator and we see that theta is equal to 71,57 degrees. Now we go to where the tangent is only with the angle that we were given originally. So the tangent theta minus 45 degrees is equal to this ratio. This ratio is positive and a tangent is positive in the first quadrant and we already calculated that angle. But it's also positive between 180 and 270. So we use 180 plus the angle that we already calculated. So 180 plus 71,57 gives us 251,57 degrees. And these are the two angles that makes this function true. Excellent. See you again next time. Bye.